All right, so we have a box at rest on a horizontal surface, and we know it's 50 newtons. Let's see, in the free body diagram, there's an FG, and that's the 50 minus 50. That means that, notice I'm going right to town on this. I'm not even reading the rest of the question. The force normal is 50 newtons. All right. Coefficient of static friction. So mu S is 0.50, and mu kinetic, we're told, is 0.30. A horizontal force, we're told it's at rest. V0 equals 0. So a force of 20 newtons is applied this way, applied in this direction. Well, let's see. We know the force of friction is mu times the force normal. And we know the force normal then is positive 50. So let's find out what the coefficient of static friction is, or the force of static friction. So that's 0.5 times 50, which is 25 newtons. So the static friction is 25 newtons. Well, friction can't win. It's not going to accelerate to the left. What this means is that this force of 20 newtons is not big enough to overcome the static friction. Remember in our force time graph we did on this lesson that we started pulling on an object and the force increased. Increased until it broke free, and we had constant velocity. And so this was the mu dynamic or kinetic. This was the mu static. Now, if we were then to calculate the mu force of friction dynamic, we get 0.30 times 50, which is 15 newtons, which is less. So this force here is 15 newtons, and this force here is 25 newtons, but the force applied is a mere 20 newtons. The force never gets high enough to break free, but if it had been broken free, then there's certainly enough to keep it going. So the acceleration experience will be 0. That block will not move. Always start with the static, then calculate the dynamic.